Okay, so today we'll be discussing how to determine what a structure and the compound is if we only have IR and MS pictures. So something like this is an IR diagram, and how it looks like a whole bunch of squiggly lines until we decipher what it really means. With IR, there are actually 5 different zones within the wave number diagram. So at the beginning, there should be a zone 1, which would consist of about 3700 to 3200. And so for this one, we do not actually have anything within zone 1. For zone 2, we have 3200 to 2700, and we do have something right here. This little guy already highlighted looks like an sp2 orbital. An sp2 orbital is located within this region. So moving on, we don't see anything over there until quite a while difference. Zone 3 is 2300 to 2000, and there's nothing there. Zone 4 is 1850 to 1650. And we start getting some stuff around here. So let's keep on going to zone 5, and that is 1680 to 1450. So right in here, we have some major peaks right now. So this in this area can only be a benzene, typically a benzene. There is one more option of an amide, but we do not have that, or the other option would be an alkene. So let's just hypothetically go with the benzene. So this whole region over here is a whole bunch of nothing. We call this the fingerprint region, and with further investigation, you could decipher this, but for, whoop, I spelled finger wrong. For this, we're not going to do anything with this, so we're just going to cross that out. So we've narrowed it down to an sp2, and benzene or benzenes are present. So let's move on to MS, and that's something else that's going to help us with this as well. So this is to decipher MS. This shows where peaks are, and something that would also work for that would be this kind of diagram as well. So with this, the major peak, and I actually like this one better than this one, it's a little bit more in-depth. There is a major peak at 249, and we're going to call that our molar mass of the compound. So 249, we're going to move on down to like the beginning of the major peaks, or the beginning of the other peaks, and right, oh, where's my mouse? Right between here to here, we're going to really focus on this, not too much so of that over there. And from here to here, it looks like about an 18 difference. And 18 would be translated into a molar mass, and we can conclude with subtracting this area from this area number-wise, it'll give us about 18, which shows that there's a presence of a fluorine there. And going back to here, we have a 3-to-1 ratio. There's 3 over here, and then the one major peak. So we're, and height-wise as well, we're going to assume that there is a bromine. So we've narrowed it down to sp2 orbitals and benzenes with the presence of bromine and a fluorine. So if we have 249 as a molar mass, really there's no presence of oxygens or nitrogens, so we only have carbons and hydrogens left. So subtracting 79 and 18 from 249, we are left with 152 molar mass. So we're going to divide that up among carbons and hydrogens. So we can hypothetically say that there's 12 carbons, which gives us 144, and then 8 hydrogens, which would give us 8, and then 1 bromine and 1 fluorine. So we're going to go with this, and we can always change this up if this is wrong. So let's try to draw out a structure using benzene's sp2, 12 carbons, and 8 hydrogens, and see where that gets us. Which, if we go ahead and try to draw out a structure, we're going to start out with, let's do a benzene. And let's do another benzene because there's 12 carbons, right? Oops, and my benzenes aren't the best, and let's stick, of course benzenes have the double bonds. And there's 8 hydrogens. So let's stick on a bromine somewhere. Let's stick on a fluorine. And then we let's connect these two with a bond. So if you added up all the carbons, like the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, we have 12 carbons with the bromine and the fluorine, and added up the hydrogens, that should leave us with this structure. And it looks like this is a viable structure.